Geometry with Mrs. Berry. This is Lesson 63. In Chapter 10, we're talking about volume. Today, we'll talk about the volume formulas for prisms and cylinders. We encounter volume in daily life all the time. Can you think of some ways that you encounter volume? Hopefully, you've thought about baking, measuring ingredients in volume, perhaps shopping at the store. If you want to compare prices, you have to compare the price per volume. You might use volume in chemistry when mixing chemicals together. What about carpenters or painters? Painters especially measuring gallons of paint to see how much they can get done. Filling your car with gas is volume. Or even just trying to fit leftovers into the right size container. Volume is the measure of the amount of space contained in a solid. You use cubic units to measure volume, such as cubic inches. What other cubic measurements? Cubic feet, which would look like this. Cubic meters. Cubic yards, cubic centimeters. There are many different measurements that we may use for volume. The volume of an object is the number of unit cubes that completely fill the space within the object. Our first investigation for the volume of right rectangular prisms. Find the volume of each rectangular prism in cubic centimeters. For this one here, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this first side in here. There's 12 on this side, there's 12 on the other side, so that would be 24 cubic centimeters. We could also say that it's 2 by 4 on the bottom, or 8, and it's 3 high. 8 times 3 is 24. Let's look at the second one. It's 3 by 12 on the bottom. That's 36 for the area of the base times 8 blocks high. 36 times 8, 288 cubic centimeters. This last one is really big, but we can still use the same method. 10 across here by 30 long. That's 300 cubes in the bottom. And then there's 10 layers. That's 3,000 of these cubic centimeters in the whole thing. So how did we find the area of the base? How do we use that area of the base to find the total? We said the area of the base was length times width, and then the total was the area of the base times the height. What formula could we use for these right rectangular prisms? Length times width times height. So if B is the area of the base, that was our length times width of a right rectangular prism, and H is the height, the formula for the volume would be the base times the height. Remember, we discovered that we could reshape parallelograms, triangles, trapezoids, and circles into rectangles to find their area. We could apply that same method to find the area of bases that have these shapes. Then we can multiply that area of the base by the height of the prism to find its volume. Try finding the volume of this right rectangular prism. If we count across, we find that there's 8 this way and 8 this way. If it's a right triangle, then we know that 8 is the base and 8 is the height. So 1/2 8 times 8. So 1/2 of 64 would be 32. That's the area of the base. Then we would only need to know the height to find the volume. First conjecture, if B is the area of the base and H is the height, then our formula for volume was base times height. Then as we got different shaped bases, we still found that B is the area of the base, H is the area of the height, then the formula for the volume is still base times height. What about if we have an oblique prism or cylinder? Let's think about a stack of congruent papers. We can use this as our rectangular right prism, approximate the volume. So this stack is about 2 inches high. If it's 8.5 by 11 paper times 2 inches high, then that stack of paper has a volume of about 187 inches cubed. Nudge the papers until you have an oblique prism. What's the volume now? Did the amount of paper change? No, so the volume should be the same. What does this tell you about the volume of any oblique prism or cylinder? Watch this as we make this an oblique prism. The volume of those papers didn't change. We didn't add or take away any paper. We could still calculate the volume in the same way. So our third conjecture is the volume of an oblique prism or cylinder is the same as the volume of a right prism or cylinder that has the same base and the same height. Let's combine all of these. Our prism cylinder volume conjecture. The volume of a prism or a cylinder is always the area of the base times the height. Now remember, with all these investigations, we had the same volume formula applying to all the prisms and cylinders, regardless of the shape of base. Remember that in an oblique cylinder or prism, we have to use the perpendicular height. So that may not be the lateral edge anymore. Use the perpendicular height for the height of the prism. Find the volume of a right trapezoidal prism that has a height of 15 centimeters. Let's draw our trapezoid. Make it a prism. The height is 15 centimeters. The two bases of the trapezoid measure 4 centimeters and 8 centimeters, and the height of the trapezoid is 5. So the area of the base, that is going to be 1/2 base plus base times height for the trapezoid. So 1/2, 4 plus 8 plus 5. 4 plus 8 is 12. Half of 12 is 6. 6 times 5 is 30. And that's centimeters squared. That's the area of the base. For the volume, we're going to do base times height. So we take that 30 centimeters squared and multiply it by the height of the prism, which is 15 centimeters. Now we have it as 450 centimeters cubed. You see we have square centimeters and centimeters multiplied together to be centimeters cubed. We are always going to have cubic units when we're working with volume. Example 2. Find the volume of an oblique cylinder that has a base with a radius of 6 inches and a height of 7 inches. So we have our picture here. The area of the base is the area of a circle. That's pi r squared. And for volume, we will multiply that by the height. So we have pi 6 inches squared times 7 inches. So 6 squared is 36 times 7 is 252 pi inches cubed. And if we want to approximate that, we can do 252 times 3.14, which is about 791.7 inches cubed. Our last example. Find the volume of a right cylinder with a 90-degree slice removed when the radius of the circular base is 6 centimeters and the height of the cylinder is 12 centimeters. First, I want to think about what happens when we remove 90 degrees or 90-degree slice from this circle. What fraction of the circle do we have left? We have 3/4 of it. So when I do my volume calculation, I'm going to take 3/4 of it. My volume calculation is the area of the base, which is pi r squared. My r is 6 centimeters. And then the volume of the area of the base times the height of 12 centimeters would give me my total volume. Six centimeters squared times 12 centimeters is 432, and this is now centimeters cubed. 3/4 of 432 is 324. And then if you want to approximate it, you multiply by 3.14, and you get 1017.9 centimeters cubed.